Hello, I'm Michael Holly. I'm presenting a work in progress project at the Institute of Interactive System and Data Science at Graz University of Technology. We are working on an interactive chess puzzle simulation to enhance students' motivation in learning computer science. During the pandemic, chess has turned into a trendy game. Inspired by the streaming series The Queen's Gambit, millions of people become fascinated by chess. The famous chess website chess.com has added a few new bots related to the series characters to benefit from the series' popularity. Since 2020, the site has counted millions of new registrations. It shows that the hype around the series and chess can be used to motivate people to play and get involved with the topic. Chess enhances strategic thinking, stimulates intellectual creativity, and improves problem solving. These skills are also essential in the field of computer science. A variety of concepts and methods have already been developed to improve educational instructions in the field of computer science. Studies showed that digital gaming concepts increase the motivation in learning computer science concepts. Interactive simulations, visualization, as well as gamified learning environments can be used to support teaching. Animations and simulations provide self-directed learning and enhance engagement and motivation. For CS topics, simulation environments reduce complexity by making concepts more understandable. Chess can be a valuable extension for learning while having fun. Chess not only affects the evaluation of social emotion, but it also increases the skills in problem solving as well as the cognitive abilities of frequently chess playing children. Chess can also improve concentration, creativity, as well as self-esteem. It has positive impact on planning tasks that require the ability to think ahead. Chess has rarely been used in computer science education. In discrete mathematics course, small chess tasks were integrated to increase learners' motivation. The chess assignments could be solved by using different theories and algorithms of graph theory. Students had to figure out the solution for the knight-duel problem of a reduced chessboard. Chess was also used into different computer science classes to teach structured and well-designed software development. Programming assignments were based on the chess engine, where students had to modify and extend them. While various studies already have shown the positive effect of digital game-based learning approaches to increasing the motivation, we want to use the hype around chess to increase students' motivation in learning computer science concepts. As a starting point, we used a virtual laboratory environment with different interactive and engaging learning methods to motivate students for computer science. The environment provides an immersive 3D lab experience and makes learning more enjoyable. Users can navigate through a laboratory hub and are able to explore a variety of simulation and experiments. The framework is implemented in Unity and supports various platforms such as desktop or web-based applications for a high level of availability. The goal of the chess puzzle simulation is to teach the concept of state machines in a simple manner. Users should get involved in the topic by solving different chess puzzles. The figure on the right shows the chessboard with the loaded scenario. Each scenario contains a puzzle with different pieces. The main task is to capture all enemy pieces on the board. User can add new states and rules by defining the state transitions, the move option, and the input field. The added rules are shown in the state transition table and can be modified by the user. When switching to the play mode, the state machine starts and moves all figures step by step. The aim of the study was to investigate the impact of playing chess on the students' motivation and emotion while learning conceptual aspects. We conducted a user study with 35 students using an interactive chess puzzle simulation integrated into a virtual learning environment. The research focus of the study was on user experience and engagement, learning experience, and workload. The study was set up as an online survey where the user worked individually using the provided guidelines. It included a pre-questionnaire, the task in the learning application, the workload questionnaire, and a post-questionnaire. We used the NASA task load index to assess the cognitive workload and the task effectiveness after each scenario. In the post-questionnaire, students were asked to answer open-ended questions about their overall experience, questions about their motivation and learning experience, and questions regarding usability and their emotions. In general, users rated the chess puzzle simulation as interesting and enjoyable. The table shows the results of the combined computer emotion scale items for CS students and non-CS students. The rating of emotions referring to happiness was quite moderate. Non-CS students rated happiness much lower than CS students. The emotion of sadness, anger, and anxiety was rated as low, while non-CS students felt more often frustrated and helpless. Both groups rated the usability as moderate. Non-CS students found that they need support to use the system. In general, most users were motivated to learn with the tool as they perceived it as an interesting, engaging, and useful tool to supplement regular learning. CS students rated it as a good idea to use it for learning. Both groups agreed that they learned something when solving the chess puzzles. CS students found the application interesting, engaging, and fun. In contrast, non-CS students were less engaged and had a reduced sense of fun. Nevertheless, most users were inspired to learn more about state machines. Users had to perform 3 different chess puzzles. The scenarios differ in the number of pieces, the positions, and the possible movements. After each puzzle scenario, we asked them to rate their workload. Most CS students were able to solve the first scenario. The second scenario was solved by 74% of CS students and 15% of non-CS students. Most students had troubles to solve the third one. The figure shows an increased cognitive workload for CS students, where non-CS students had a consistent workload level for the second and third scenario. In conclusion, the participants indicated that they felt more motivated and believed that the chess puzzle made the topic more engaging. The different scenarios have shown to be a good motivation. The results show that the workload has to be adapted to the user's skills. Usability was rated as okay, but there is still place for improvements to reduce the frustration level. Using additional motivation techniques could contribute to a better learning experience. Future studies could focus on the implementation of such a chess-based learning approach for school classes to evaluate children's motivation for computer science. Many thanks for your attention, and we are looking forward to your feedback.